Alright, so continuing the design of my motor control board, I really need to start laying it out or actually routing it pretty soon. But what I'll do first is go over all of the DRC rules so that we can get everything noted down. And I'm going to go to drawings layer here, and I'm going to do some drawings. So this is going to be a 4-layer board. So we can draw 4 layers, and this is just to make sure that we have everything on the on this PCB drawing. Any assumptions that we make about the PCB is going to be here. All right, so let's make a little drawing here. I think I'll have 1 OZ copper, and those things you have to check with the manufacturer that manufactures the board, which minimum requirements they have. Usually you can have 6/6 mil boards at normal price, and if you go down to like 2/2 mil boards would be extra price. And also you can have different thickness of the copper, so 1 OZ is pretty standard. You can have thicker copper, but it also gets sort of more expensive to have thicker copper. I'll start with 1 OZ, and I'll be doing my calculations based on 1 OZ. If I need to have thicker traces, I can use all 4 layers to sort of get to maximize the thickness of the copper. So I'll go with 1 OZ for now. And then we have the prepreg. Oh, actually, let's do it like this. Damn. I have a grid that's unnecessarily large or small. Now it's better. Now it's bigger. Okay. All right. 25 is better. And the distance between the top layer and the first inner layer would be 0.2 millimeters. And after that we have a distance of 1.2. So it's going to be 1.6 millimeters board. 1.2 millimeters. And things like this are important because if you're going to calculate, for example, impedances of certain traces and adjust the impedances of traces, then it's important to know which layer you're going to be routing on and what you have underneath. So I'll have ground layer on the second layer from the top, and then I'll have power below that, and I'll have another signal layer on the back. And the reason for this, for doing it this way, for me, like obviously you can choose any kind of layout you want, but I think that having signal layers on the outside of the PCB is nice, because you can, if there's anything you need to modify, like whatever, you need to do something to a signal, maybe cut a trace or solder together 2 traces, then having them exposed is much better than having them somewhere inside the board. And also, because there is only 0.2 millimeters to the ground, I can route signal layers at the top layer, or signal traces at the top layer, which can be referenced to this ground, and they'll be pretty close to that ground and nothing in between those traces and the ground, like no other layers. So this one will be, let's do like this actually. So there'll be one OZ, and I think this would be probably 0.75. I'll have to check. And let's see. Let's actually pick any PCB manufacturer for now, for the sake of this video, and use the data from the internet as basis for making this diagram. So I'll just copy this and I'll go here. I think Seed Studio is a good starting point, but obviously you could choose anything that is either local or some that you used before. So this would be 0.75 LZ, and copy. Let's see. Maybe I can actually do like this. No. Did it actually? No, it didn't select them. Okay. So apparently with drawings you cannot align them. Okay. And I'm gonna have 6/6 traces. And 6 mil is, I think, 0.15 millimeters. I have to deal with mils. I don't like mils at all. Yeah, 0.15 millimeters. Minimum via size, we can go with actually the standard Seed Studio. Or should I just make a search in Google? Like, for the sake of the video, just let's make a search in Google and just see what we find. So suppose we were gonna like manufacture this PCB, so we want to find a manufacturer. So PCB manufacturer, cheap. Like there's so many PCB manufacturers, it's almost like just pick one. Just pick one. Yeah. So let's go to Seed Studio. Actually, I'm gonna do like this. So they can go, for example, to 4/4 mil, and 6/6 mil is kind of the standard. There is no reason to go smaller unless we're doing any kind of BGA routing or something that actually requires really thin traces. Minimum spacing from trace to vias. And also, besides putting it here, I'm also going to put it in the DRC rules. But first I'm going to note everything down on the drawing, and then I'll do the DRC rules from that. So minimum trace width in inner layers, right? More than 6 mil. Right. We have minimum distance between trace and copper pore, 8 mil. And 8 mil is how much? .2. Next. Distance between vias. So this is between the holes, and first we have to check the. Actually, I'm going to make this 15.2. So first we have to check the annual ring, which is 6 mil, and this distance needs to be 12 mil. Interesting. Does this mean that the vias can be just right next to each other? Oh, okay, right. This is actually between the, so it's from the edge of the hole, right? And this, yeah, this is strange. So what would be the distance between the actual copper? I suppose we would go with 6 mil there. So we have to have. It's actually going to be more than 12 mil there. Actually more like 18 mil. Anyway, minimum distance between via and trace. All right. Mil. Right, so it's going to be 0.5 OZ on the inner layers. Width of this is the minimum solder mask, the width of minimum solder mask trace. Right. 12 mil. VGA is not interesting for this. Minimum silk screen height. Let's make this like, okay, yeah, 5842, 23 mil, and silk screen. Let's see. Million slot is what would be like around the PCB if you have multiple PCBs in a panel. Slot tolerance. Aluminum board specifications. Right. The distance between non-plated hole and inner trace. This will actually be covered for the pores. It will be covered with clearance, and for traces, it would be let's see. Actually, this would be important consideration also. Because if I set the clearance to 6 mil, then it will be lower than this minimum clearance specified there. So minimum distance, let's put this here. Yeah. All right. Okay, so we can set up some basic DRC rules. KiCad DRC rules aren't very good, but it still can sort of check the basics. Set up design rules. We have the default track width. Let's make this 0.16. Or actually I'll make the defaults the minimum clearance 152. Via diameters, I think they specified actually the minimum hole size. So 0.2, and actually via diameter would be 0.5, and 0.2 is the hole. Diff pair width, this will be set separately. And I'll set up a few custom sizes as well. So next would be 0.4, and the diameter will have to be 0.4 plus 0.15 times 2. So 0.7 would be the diameter then. The diameter is the full diameter of the via, including the copper, and the drill is just the hole. 0.6 and 0.9. And the custom track width, let's see. Let's see what currents we'll have here. I'll need, I can use 0. Oh, actually I can't scroll there unless I close this. Yeah. I can use 0.15 for most of the traces, besides the power traces. But I'll need a little bit thicker traces for the motor signaling. And obviously for the power, I'll have to have really thick traces. Okay, so track width we can calculate for 1.2 amps. Temperature rise, let's make this 25 degrees. Conductor length, let's make this 20 millimeters. And we can actually do this with 0.22, which is 8 mil, bit over 8 mil, so maybe 10 mil. So 10 mil would be for 0.25 would be for the traces that go to the to the motor drive chips. Let's see. And then we have 3 amps. I think let's do this 3.5 amps. This would be for the power that is 3.5 amps. Trace width 1 millimeter. And let's see, for the 20 amps, we need to have 1 centimeter traces. But because we can actually fold them together and put them on multiple layers, we could actually get away with 0.25 millimeter traces. That's the smallest, but of course I'll use thicker. Let's or like, sorry, 2.5 millimeter traces. Yeah, that's what I meant, because it was 10 millimeters for 20. Yeah. So 40 would be 28 millimeters. It doesn't really make sense to have 3 centimeter wide trace, but because this is not an isolated trace, it's kind of, it's not like hanging. It's not going through a board with nothing else around it. It has a ground plane that is very good at leading away the heat right underneath it. If this is going on the top layer, and there's a lot of copper and components also around that absorb the heat as well. As long as the heat can go through the PCB to the large ground plane, it can be led away a little bit better than if this trace was just a single trace on the board. So for 40 amps we would need something like 28 millimeters. I'm gonna see here. So oh, there we go. So the trace here will be something like this. 9 millimeters maybe, or at least 425. Yeah, let's make this 5 millimeters. Oh, damn it. There we go. I think this is enough for now. Not class editor. Yeah, that's fine for now. So now I have all of the custom track widths here and wires here. And I'm I'm gonna have to make sure that my current vias comply with the design rules that I just set. Yeah. That's fine, and I have the 5-volt regulator somewhere, which I think could have some vias that are too small. 0.2, 0.5, and the 5-volt here. Oh, that was fine. Okay, so all of the existing vias should be fine. And I could start routing some of the traces actually. So this would be 5 millimeters. By the way, when you have things like the ground frame here, if you just click on the inside of this ground frame, you select the ground frame, right? And this can be very annoying because if you suddenly want to like select other components, every time you click somewhere, you select the ground frame first. But there's a very nice workaround around this, which is by using the multiple select functionality by just pressing Shift. So if I deselect that and I press Shift, I can just select inside whatever area I want without selecting the ground frame around this. So just pressing Shift kind of solves that issue. I kind of wonder if this is really the best way, considering that the tracks are so large. What I'll do actually is I'll add a fill here. Let's add a ground plane first. So I'll go to the inner layer and I'll draw a ground plane. And on the front, on the top layer, I can create the connections for the power input here. So I'll go, let's see. I'm just thinking of the best way to do this. I think I can just do like this. Power in. Not in. So if I hold Control, I can draw straight lines. I'm going to use thermal relief for this. But it doesn't have to be, let's see, clearance would follow the rules that we have defined in the drawing here. So we have minimum space to copper, clearance 0.2. Make this, we can actually calculate electrical spacing. So I should be going between 51 and 100 volts, and I could use B2 and B3 because even though this is for uncoated, this gives, let's see, this gives a bit more margin. So the traces on the PCB actually are going to be coated. permanent polymer coating. So we could actually use 0.5 is probably a good idea. Anti-pad clearance is just for the clearance between the area and the pads that it connects to. So it doesn't really matter from the electrical isolation. It's just for the heat, the thermal relief. And VMOT will go all the way here, so all of this will be just one VMOT conductor. I'll put it in the back, on the back layer, and on the inner layers as well. So I'll actually probably remove parts of this, some of the vias there specifically. Let's see. We'll actually have to go on all of the layers. And here I'll just have no thermal relief at all. So this will just go straight to the pads themselves. Let's enhance this footprint actually. I'm going to place vias that will go to the inner layers. I'm going to serve as a low impedance connection to the supporting layers that will support the leading out of the heat from this pad. And I'm copying, making a copy of this this pad, but without any silk screen and without any paste and mask. So what this does is it creates just the copper. And we can make the size of this. Let's see here. The size can go all the way here. 425, maybe 5. It could be 450 times all the way here. $450 times 7. And if we look at this in 3D, we can see that this is how it will look. It will have exposed pad here where the transistor will actually solder, but then it will also have copper around it, so that it's easy to connect than any traces or just directly connecting this to the inner layers. should be possible to have copper pads on any layer. I don't know why they limit it only to the outer layers. So this will be a extra heat sink on the back. Actually this the stuff on the back is actually not optimal, because we want to have the VMOT running straight through, and if we have wires here we can't actually do that. No? And on the back, I'll actually do this differently. No, I'll do it like this. Okay, I'm gonna check how much we have here. 0.25. Okay, how does this look? Let's yeah, it looks pretty nice actually. The only thing is, for example, this resist or this capacitor here. I have to actually move it a little bit. I wonder if this will complain about pads overlapping even though they have the same signal on them. Otherwise it would be actually pretty good, I think. So let's see, on the front it will look like this. With the leads just coming out here and going to the outputs. And can we flip this? And on the back it will look like this. And also going to the outputs, except that I think I'll add a few more vias here. And these vias that are coming out on the other side will be connected to the same, or actually no, they will not be connected to the output. So I think it's probably better to remove them actually, because the inner layer will be just the VMOT entirely. Yeah. So even though I have direct connection here, even Alice, nej, lovely. Even though I have direct connection on the top here, I still have to make sure that I have enough vias going to the... Alice, nej, nej. Lovely. It's my dog. She's making... She's again, like she's got stuff stuck to her and she's zapping me with static electricity after she's rolling on this floor here. Everything sticks to her when she does this. Lovely. Los? Yeah. yeah. This is probably the most boring video so far. I feel totally unmotivated to make a video today. Come, Alice, come. Come. Här, plats. 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 Ligg. Nej. Vad blir? Nej. Nej. Ligg. 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 Nej. Vad blir? Nej. Ligg. Så. Bra. Loss. Loss. Bra. Okay, I'm gonna finish this video right now and just continue later today.